Okay, so we're going to kind of do some review, and then we're going to go into some different types of problems that you might encounter that deal with imaginary numbers. I'm going to show you how to work some of these out. So the first thing we've got here is x minus 1 equals 0. So what you should be able to do is approach this problem pretty easily. So if I have x minus 1 is equal to 0, I can add 1 to both sides. So I get x equals 1. So that's a pretty easy solution. Oops. The second question is x plus 1 equals 0, which is going to be really similar. Right, I'm going to set it equal to 0 and then subtract 1 from both sides. And I get x equals negative 1. And then scroll on down here. You've got x squared minus 1 equals 0. So that should be pretty familiar because we've done a lot of these. So x squared minus 1 equals 0. All right, you add 1 to both sides. You get x squared equals positive 1. So then you take a square root. And whenever you take a square root of a square, you get two solutions on the right-hand side, plus minus 1. So x equals plus and minus 1. And then we've got this last one, which is x squared plus 1 equals 0. And so that might be a confusing one because you've never encountered it before. And whenever you try to solve it algebraically, you get a weird answer. You get x squared equals negative 1, and then you get x equals plus or minus the square root of negative 1. And so from our last conversation, if you remember that, square root of negative 1 is actually a very specific identity in math. It's I, which we call the imaginary number. Sometimes they're called different things like lateral numbers. That way you're not trying to assign some value to it that is elusive. But take it at face value. That is how you solve that quadratic. That is one way to solve a quadratic at least. And so with a lot of these, you're going to be dealing with complex numbers, okay? And where they come up, so they come up a lot in quadratics and different polynomials. And then there are ways there are mathematical principles to apply to these complex numbers. And one of the first things that you'll learn with complex numbers is how to add them, okay? So that's kind of the goal. Add, subtract, multiply, and even divide by complex numbers, okay? So we're going to deal with this first. So you've got addition with complex numbers. So we have 3 plus 4i plus 7 minus 20i. So we're going to do this one together. And so I encourage you, if you kind of get the idea, you can pause the video, or if you're going back and reviewing these problems, pause the video, see if you can get it. But 3 plus 7 is going to be 10. And then 4 plus a negative 20, well, that's the same as subtracting 20 from 4. So that's going to be negative 16i. So that's the solution to that problem. And then you're not going to take it any further because negative 16i and 10 do not commute. They're not, it's really similar to saying 10 minus 16x, right? You've got a constant term and then a variable term. Over here, I isn't a variable, but it's a number that doesn't commute with real numbers. So this is a complex imaginary only part, and then this is a real part, okay? So let's do another one. So you got addition, and then we got subtraction. So subtraction, just remember that this negative, and if it's in front of parentheses, it's going to distribute to both terms. So if something's positive and you've got a negative out front, that positive will become a negative, and this negative will become a positive. So I'm going to show that. So let me write this out. And it's trying to show you that these are very similar problems, but the answers are going to be completely different because of that subtraction symbol. So even though they have similar numbers involved, the answer isn't going to be just the opposite opposite. It's not going to be like negative 10 plus 16i. You're going to have to work the problem out. So you've got negative out front, and it distributes. So you got 3 plus 4i minus 7 plus 20i. So 3 minus 7 is negative 4. 4i plus 24i is 4. Negative 4 plus 24i. And that's all you have to do. But if you'll notice, 10 minus 16i doesn't look anything like this guy down here. Okay? So it's going to work out quite different than what you might expect. So let's look at a few more of these. So now we know how to add and subtract. Now let's look at multiplication. So you've got actually a conjugate pair here. And what you're going to notice is that this works out really nice. And even though it seems like a really complex, literally complex expression, it's actually going to simplify really, really nice because there's an identity that we can use with this. But I'm going to walk it out in explicit detail. So 1 plus 2i, 1 minus 2i. So 1 times 1 is 1. 1 times negative 2i is negative 2i. 2i times 1 is positive 2i. And then 2i times negative 2i, you got to be careful here. 2 times negative 2 is negative 4. I times I is I squared. So if that's the case, I've got 1 minus 2i plus 2i will cancel. They'll add to 0. Don't want to say cancel too often. And then I squared is negative 1. So negative 4 times negative 1. So this I squared is negative 1 because of an identity. So if you're unsure of that, you probably need to go watch the previous video in this unit. So if you're unsure this step to this step, I would definitely go watch that video. But negative 4 times negative 1 is positive 4. So I've got 1 plus 4, which is 5. Okay, so all of that to say that that entire expression to start with is actually equal to 5. So we showed that. And so the reason why we study a lot of these numbers is not because they're not useful or we want to just hold math over your head. These imaginary numbers are very applicable to things like physics, but just because they start as something we can't think about very, very concretely does not mean they won't pop in and out of existence in math problems. So even though this may not look like something that's tangible, it actually equals a number that you can think of in each day, everyday life. So this is actually equal to 5. Okay, let's take a look at some more. It said verify that negative 1 plus 2i and negative 1 minus 2i are solutions to this quadratic. We can actually do that. All we have to do is plug those in for x, and then we have to verify it. So we're going to do that. So I've got x squared plus 2x plus 5. And I'm going to start with negative 1 plus or minus 2i. So we're going to check these as x. So let me just write those down and we'll get right into it. So I'm going to plot these and just plug these in for x here. So I've got negative 1 plus 2i squared plus 2 times negative 1 plus 2i plus 5. And we make sure that this equals 0. I think that's what we're trying to do. So let me just double check there. Yeah. So there's solutions to the equation x squared plus 2x plus 5 equals 0. And we're going to show that. And so everywhere that I saw an x up here, I just plugged in negative 1 plus 2i. And then I'm going to plug in negative 1 minus 2i. So whenever you square a quantity like this, don't distribute the square. I've said this a few times, but you might not remember it. But don't distribute the square. You're going to write it twice. And then this 2 distributes. I get negative 2 plus 4i plus 5. And then I'm going to have to distribute all this stuff out. So I've got negative 1 times negative 1. Negative 1 times 2i. So negative 1 times negative 1 is 1. Negative 1 times 2i is negative 2i. And then I've got 2i times negative 1 is another negative 2i. And then I've got 2i times 2i is positive 4i squared minus 2 plus 4i plus 5. So I'm going to try and clean this up a little bit. I've got 1 minus 4i plus 4i, 4i squared minus 2 plus 4i plus 5. So what you'll notice is that, again, from that previous video, I squared is equal to negative 1. Okay? So if I squared is equal to negative 1, I've got 1 minus 4i minus 4 minus 2 plus 4i plus 5. So what I can do is combine some of these like terms. 1 minus 4 is negative 3. Negative 3 minus 2 is negative 5. So that's going to be negative 5 plus 5, right? And then negative 4i plus 4i. And so I think I'm going to cut this one short. I'm going to show the other one in the next video, but it's very similar. I'll just leave it to you as an exercise. That's a better idea. I'll just leave it to you as an exercise. But negative 5 plus 5 cancel out, and then negative 4i plus 4i will add to 0. So indeed, if I plug one of those in, you're going to get 0. And so just because it's a complex solution to a quadratic does not mean that if you don't plug it in, if you plug it in, you won't get something tangible. So we got back 0. So that's a real number. Okay, so it's very important they show up in math quite a bit, and you're going to need to know them. Thanks.